All right, are we there? I must apologize about not letting you know earlier, but I'm a little under the weather today, so I thought it might be best just to do this way. Um, I'm going to do an experiment on. I'm going to do an experiment here at the end of this problem here, but let's just do this one. It seems interesting to me, at least. Um, and then I'll describe the experiment we're going to do in a minute. Okay, so it says a cue ball with an initial velocity. One thing about this, okay, well, we'll read through the whole thing. The cue ball with an initial velocity of 5 makes a direct collision with the ball, and it looks like they're going directly, so the impact is directly into each other, so there's no oblique impact here. Determine the velocity of B and the angle just after it rebounds from the cushion. So he has this and he has this. So first let's deal with this impact. Then after that we're going to deal with this impact, because this impact is an oblique impact. Okay, so here we go. MA. Oh, now let's see. Each ball has a mass of this. So MA VA initial plus MB VB initial equals to MA VA final plus MB VB final, all the same masses. Okay, the line of impact, and we're basically finding this is the velocity here. So B is supposed to be sitting still. So the initial velocity of B is this. This is 5 equals to VA final plus VB final. And that's all we got. Now we have this, which the coefficient of restitution, E, is equal to VA final minus VB final, VB initial minus VA initial. Okay, VB initial was nothing. This was 5. So now I have E. Now if I've got a minus 5 here, what I'm about to do might seem confusing, but I'll explain it to you in a minute. Okay, so I've got this. So if I multiply the top and bottom by a minus number, I get rid of that, and I put a minus here and I put a plus in front of that. So that's actually kind of what happened there. So I can bring the 5 over. So I'll say 5E is equal to VB final minus VA final. And so now I'll just take this, move it, take this again, move it right under here. But you know what? Instead of moving it now, I'm going to basically say this gives you that. So the E for this was 0.8. So 5 times 0.8. And now I can 5.8 equals to VB final plus minus VA final. I just swapped these two terms. The reason I did that is because now I can add equation 1 and 2 to get 1 plus 2, and the equation would be devoid of the A because they're non-existent. So 5 plus 5 times 0.8 equals to 2 VB final. Just go ahead and use my cell phone here. Be 9 would be VB final is equal to 4.5. Now, I have done the impact in this direction. This is the plus impact. So now B is going 4.5 like that. Let's look at problem 2. Problem 2 deals with the impact that B has with the wall here. So let's go ahead and look at that problem. We will do this. So what we'll do is mass of C initial. Wait a minute. Okay, so now we're looking at B and C. Mass of B, VB initial, plus mass of C, VC initial, equals to the mass of B, VB final, plus the mass of C, VC final. Now we got a problem. Okay, so what I'm going to do is go back to the picture. Try to get a bigger picture here. And okay, this time I'm interested in only, well, I'll go ahead and do that. Okay, let's see. Computer's moving very slow today. Okay, now for the problem we're interested in, this is 4.5. However, let me kind of get in here a little better at this. So here's 4.5. It's broken into a component here and broken into a component here. This, in fact, is the 30-degree line. So this component, 4.5 cosine of 30. This component, 4.5 sine of 30. Oops. So now the impact occurs along this line. The impact plane is right here. So if I were to list this in actual terms, where I look at this as being X and this as being Y, VB initial before the impact would be minus 4.5 cosine of 30 I, because it's going the opposite direction, This is going the opposite direction of that. And it would be minus, because this is going the opposite direction of the y, minus 4.5 sine of 30j. I'll go ahead and, I'm not going to be exact with this. I'm going to just use my calculator here. Okay, sine. This is going to be minus 2.25j and minus 3.897i. So this is what I got. Now here's, okay, so I had this equation up here, and wow, it's written very big. Here's something interesting, okay, the initial velocity and the final velocity of the pool table can be assumed to be pretty much nothing. So now you have kind of, and the mass of the ball is the same. So you've got a problem here. So what's up with that? Now, before you go any further, let's take a look at something interesting here. And let's consider a, because this doesn't really fit. But let's look at something different. Let's consider a basketball. Okay, so if I drop a basketball down, it hits the ground and it returns up. Let's say I drop it such that the velocity is equal to 10. Okay, this is the Earth, really big Earth, a lot of space, a lot of mass, not going to be effective here. So if I look at this coefficient of restitution, now it turns out there is a rule in the national basketball as well as the NCAA about how high a ball should return. If the ball comes all the way back, which it's not going to, that's kind of against the rules. So let's say the velocity off the surface is equal to 8. So what's the coefficient of restitution? Well, first of all, we have to decide what is a plus direction. So we're going to take for this problem plus. Okay, so here's A, we'll call this A for Earth. We'll call this B for the ball. V, B final minus VA final over V, sorry, VA initial minus VB initial. Now the Earth's not moving, so you can pretty much take that out. Now, the fact of the matter is, okay, this is VB initial, this is VB final. VB initial, it's going, remember this is the plus direction, is equal to plus 10. VB final, as it comes off the ground, it's going in the opposite direction of the plus, which is equal to minus 8. So if you stick a 10 here and you stick an 8 here, you get the coefficient of restitution of 0.8. So this is similar to what's happening here. So this you get a problem with. You're like, okay, this doesn't make sense. There's something going on here. In fact, this would be fine if the coefficient of restitution were 1. So you don't even have to use this. So because of that, I'm going to go ahead and remove it. And now you only need to use one thing, and that is coefficient of restitution because of this special case, meaning It's bouncing off of a unmovable object, so to speak. In fact, if you were to look at it, the pool table does move a little bit, and it does have a mass. So making those assumptions that I made were probably not correct. So let's look at this from this standpoint. In this collision, I've got a B and a C. VB final minus C final over VC initial minus VB initial. Okay, C, and we'll pretty much say goes away. Now, the impact in this case occurs along the X. The E he gave me as 0.6. So if you look at this equation, you'll see 0.6 minus 0.6 VBI is equal to VB final. So the initial velocity along the line of impact is that number. Now let me go in here. Okay. Sorry. Times 0.6. I get a number. Okay, I have a minus sign here and a minus sign here. So I get 2.3382 is equal to VB final. Now, it's a plus, meaning that the velocity is to the right. However, in the assumption that we're making, and this is an assumption, is that this component, which is in this direction, does not change. That isn't completely exact because there could be a little bit of friction right here and it could slow it down, but for the case in point we're going to say it's not. So this makes the VB final equal to, okay, the component in the X would be 2.3382 I minus, assuming there's no friction that slowed it down in the J, you have that. Now, what you've got, man, that's pretty close to 45 degree, but not quite. What you've got is 2.25, and what you've got is 2.3382. And actually, he wants this one. So I don't know. I mean, I like to go back in and figure out what's the magnitude of the velocity is equal to 2.3382 squared plus 2.25 squared. This is an extra step because you can use the tangent, but I just want to do it this way. So 2.3382, I got to turn my calculator sideways, squared plus 2.25 squared equals to that, and then take the square root. I get a 3.24495. Now, if I want to know that, I could say the sine of that angle, whatever that is, he's designated it to be theta, is equal to 2.25 over 3.24495. So here, let's see if I can. Okay, so invert that thing, multiply it times 2.25. Then I take the inverse sine of it and get about 43.8 .898.726 degrees. That's ridiculous to carry that many digits. Now, this goes along with an impact. So you had, and you could have this with a basketball as well. In other words, somebody throws a basketball, it goes down, it bounces off the surface like that. So right before it hit, it had a velocity this way, assuming that you're losing a little energy, or meaning that E is less than 1, the angle of impact is going to be different than the angle coming off. So we can go look at the answer here. This is 1577. Let's see. I don't even think I can do that actually here. Let's see. Let me poke around to see what it is I have here. I may not have the ability to find the I mean, I don't know. Oh, wait. There are some solutions. Okay. I have already forgot the problem number. 1577. Oh gosh. Okay, wait a minute. 15. Okay, so he does find that component. So 3.24. Okay. 3.24 meters per second and 43.9. So 3.24 and 43.9. So we're good. What I'm going to do now is I'm going to basically end the lecture, but I'm going to use you as a guinea pig here. In the next lecture that I'm doing at 11, I need to do a swap of the stream. So what I'm going to do is I'm going to say the lecture's kind of officially over, but I'm going to pick it up. I'm going to watch this lecture. So you're going to hear me talking in the background. Okay. So the way I'm going to... Is it going to pick back up? All right. Is it going to pick back up? It did it. So what I essentially did was pause the stream on one machine and pick it up on the other. So it did it. So what I essentially did was pause the stream on one machine, pick it up on the other. So it did it. So what I essentially did, now I'm going to compete. All right, what we're going to do now, so I'm going to do a swap back. So I'm on a Linux machine. All right, what we're going to do now, so I'm going to do a swap back. And Linux machine. All right, what we're going to do now, so I'm going to do a swap back. Perfect. So I'm going to claim, now I've experimented on you, I'm going to claim this lecture is done. Sorry about this experiment, but now I know I can swap back and forth between machines.